just before doing that, it's worthwhile just taking a look at the image to make sure that we haven't clipped it inadvertently. The reason for saying that is that we've just applied an increase in contrast, and it's very easy to clip stars or clip the galaxy cores. So if I zoom to half life size and put my cursor on some of the stars and look at the values at the bottom, they're still bright but not too bright. They're just starting to get into the critical region. That one's almost clipping there, as is that one. And in the middle, the core is right on the cusp. And to be honest, what I should have done was, just before doing that last stretch, apply a histogram transformation that knocks it back. And let me show you a trick to save you having to do the whole thing all over again. So if I choose my image here in the history, drag out the two local histogram transformations out to here, back off twice here, and then do my histogram transformation that we did in an earlier tutorial, where I reset the histogram transformation and knock it back, give an extra 10% of headroom, and then just shrink that for a second, drag that onto there, run this process, and then repeat. So I'll come back in a second. Okay, that's the first one done. Then basically apply this the second time, shrink that down, and then apply the second one. This will be a bit quicker. So this is quite a neat trick to, if you forget to do something, just insert something into the timeline of all the processes that you do. And now I've done that, I can remove these. And if I look at the History Explorer, you'll see now it shows histogram transformation, local, histo, local. So it's a nice way of just inserting some things without losing all the set stages that you already worked out. With that in mind, let's take a look at methods of doing star shrinking. And that requires two things. It requires a star mask and then using a tool called the Morphological transformation tool, which is a real mouthful, especially after you've had 2 glasses of Rioja. Anyway, let's pull up the star mask. When you look under masks, there's 2 mask tools. There's range selection and star mask. Range selection is simply making a mask depending on the luminance value of the image, and star mask uses scale to work out what's a star and what is not, though it sometimes gets confused with things like galaxy cores or sharp nebula details. If I make this default, and what I will do to make things a bit quicker is I'm going to do a preview on part of the image that has what I'm looking for, which is a range of star sizes plus a little bit of the galaxy as well, because I want to see how it detects stars in areas where the background level changes. And if I look at that here, I can apply a standard star mask to here, which should be quite quick, and we can start to see what the different controls do. So when you line that up to there, you can see that it doesn't seem to have picked up these 2 stars. In fact, if you overlay it on here, you can see that the stars aren't really picking up properly, very slightly. In fact, there's this blob here and this blob here, which are very faint, and the reason for that is the way the star mask works. Now, I can probably improve on that by increasing this threshold here, which will make it quite less sensitive to stars. This has got a lot more blobs on it than the one underneath, so it's picking up all kinds of things, possibly even noise. So by increasing the noise threshold, it's only looking at stars which are fairly bright, which are after all the ones that we're trying to knock back. And if I increase the scale, it'll work out and look for things of bigger scale. So if I knock that up to a scale 8 and then repeat, we can see what it does. So now, quite a different result. When you overlay it on the image, you can see that it's picked up on some big stars. So these 2 here are picked up quite well, and that one's picked up, but for some bizarre reason that one hasn't. So I'm just going to shrink that down. In fact, I have a funny feeling that this tried to do a star mask on here than here. So let's just click on that and just double check. When you do these things for yourself, it's so much easier than when you're trying to talk to it at the same time. Ah, that's better. Right, so now you can see that it's picked up those two big bright stars, which is excellent, and it's picked up the other bright ones, which is just what I wanted. So this setting here with the higher scale is better than the previous one. So I can get rid of this star mask. What I might do, because star masks, they're not magic, you can't get a star mask from this tool that does everything for everybody. And sometimes what you have to do is combine masks together or run with different masks set to different stars. So if I reduce this down and go for smaller stars and small bright ones and do that, what it hopefully will do is pick up on the little stars, which it has done. And that might be useful if I want to reduce the small stars. So I'm going to shrink that to a second and that one. Now, there are other controls in this tool, one of which is each of these blobs that it creates, you can shrink and enlarge those blobs to cover an extended area, and that's sometimes useful when you're trying to mask off an area and not stretch it, or if you're trying to shrink a star down. Normally the default settings are about right for this type of image. If I had really large bloated stars, then I would hit this large scale structure growth, which would make those big white circles even bigger. You can also change the smoothness of it, so the bigger stars typically require a larger smoothness value. The smaller ones you can cope with a smaller one. And there are other things under here that alter the way the mask is generated, and I can only explain so much. Binarize basically produces white or black and nothing in between, whereas if you look at these star masks, there are things in between. Contours is an interesting one, which is very useful for fine-tuning star sizes, but it's quite finicky on its values, and it produces an annulus around a star which you then shrink down. Not for today, maybe for another time. And you can also invert the star mask as well as having the positive one. And then there are some other controls that change the clipping points on the star, so you can boost the mask a little bit. So for instance, if I drag this down, it'll boost the mask values in here and make them whiter. And that's sometimes quite useful. So for the moment I'm going to leave my two star masks, and they automatically give them incremental numbers. So you've got star mask 1 and the original star mask. And what I'm going to do is bring up a new tool called the Morphological transformation tool. And for the moment I'm just going to work on the previews because it's much faster, and then in the background I'll do it on the main image. The Morphological transformation tool is a tool that in effect uses the values within each of the mask elements to alter or shrink or expand the star. So if it's shrinking with the erosion setting, it looks at the minimum value within the mask and it tries to perpetuate that and grow it into the star core. So you get a diffuse outer and a central peak in the middle. And you can do multiple iterations and so forth, and you can alter its degree. And you can also alter the degree over which it works. So with big stars, you might want to go to 11 or even more elements. And there are a number of different types of mask. These icons in the Mac version are very small. I haven't found a way of making them larger. But the one I normally use is one here, which is called Circle. And with 7 elements, it will make a big change to big stars. With small stars you wouldn't necessarily need it as large as that. You probably could cope with 5, which just pulls it in a little bit. If you go too much, what it does is it, rather than shrink the star down, it just makes the whole star wash out, and that's typically because you've set the size too big. So let me just drag that preview out and then it will work. There we go. And just hide the mask and let's just apply the erosion. So immediately the big stars have shrunk down a little bit And the beautiful thing about using the mask and the preview is that you can undo it and redo it. So the stars have lost their intensity and they're not quite as obvious. Now there's another technique for doing this which I prefer, which is to use a different operator. So under the operators you've got erosion that basically shrinks the stars down, you've got dilation that pushes them out, and you've got various other things, of which one that's quite interesting is called morphological selection. And this one uses a combination of two processes in order to create a slightly more realistic star shape. So you get a central core with a more defined edge. And if you slide the selection down this way, it makes the stars smaller, and if you go above 0.5 it expands them. So it's quite sensitive, so I'm going to drop it down to 0.4 and try a couple of iterations, and I'm going to go up a scale and I'm going to apply it to this one here. So those big stars have shrunk down even more, but in a way that looks more natural. These big ones don't have a weird central core, and that's using this mask here. You can see there's some very large blobs here. If I was to undo that and go up even more, say to 11 elements, and drag that to there, you see those star cores now have become quite diffuse and a little bit washed out and probably gone too far. You want them to still look like stars. So I'm going to back off there and try that one. Let's see if that's where I want it to be. No, I think, again, too far. So it's going to be this one. Okay, so they've still got a central peak, which is good, and some of the smaller stars are fairly innocuous. So what I'm now going to do is apply my second star mask to my preview. What I need to do now is change my morphological tool to a smaller value, say 5 elements, and drag that to it again. So the little tiny stars have now disappeared and become a lot less obvious. So what I'm now going to do is apply this to my main image, and I'll come back in a few moments. I've now regenerated those two masks for the entire image and applied it with the morphological transformation tool, and if I undo the last two steps you can see that is where we started from, and then the bigger stars have just muted slightly and the smaller ones have disappeared, and it gives more emphasis to the galaxy over the Milky Way that you're looking through. I haven't sharpened this image in any way, and I could have done deconvolution at the beginning, although the scale of the image is probably not ideal for it. But what I will do is use one of the multi-scale tools to do a little bit of sharpening of the dust lanes before we move on to look at the colour image. So I've just tidied up the desktop a little and resized the preview to look at the central core plus some of these interesting dust lanes. And you can see it on here that I've got the detail there to try out a number of different sharpening tools. So what I'm going to do is pull up multi-scale processing median tool, drag it onto my area of the video, and the way we do sharpening is we emphasize different scales. I'm going to just increase the number of layers to 6 layers, and I'm going to start emphasizing the smaller scales, and you do that by increasing the bias of the scales. And I would not normally go above 0.1 on any scale, which is about 10%. So at scale 3, where we start to see small stars and also see structures, reminding ourselves that often the resolution of our system, optical system, is less than the resolution of the sensor, I would normally be about 0.5 or something like that. And you can use the slider, but that's too coarse, so I'd have to normally have to type these things in. I would put in something like 02 here, a little bit there and roll it off to there. And what I'm going to do is just simply on the preview drag it onto there and see what happens. Now the preview shows quite a large part of the image, and while I can undo it and redo it, you can see it's emphasised the dust lanes a little better, gives it a little bit of sharpness. I haven't been too stupid with it. What I typically would do is look at it at half life size, which is what it seems to be already, or I could go to life size. So again, if I undo and redo, you can see that it makes the stars brighter. So again, we have to watch out for clipping, and it just gives a little bit of emphasis to these crowd structures. In fact, I probably could go a little further. So what I'm going to do is I'm going to increase that. Whoops. If you double click a layer, which is what I just did accidentally, you completely disable it. And in fact, if I just take those layers out and hit apply, you'll see that it actually removes that surface of detail completely, which we don't really want. So let's just undo that, bring it back. It also took out the smaller stars, if you noticed. I'm trying to desperately avoid redecorating the house during lockdown, and this is the best excuse I can think of. So I'm going a bit extreme here. Whoops, and let's see what happens. So that's as extreme as I would want to go, and the stars got quite white. The detail on the dust lanes is now very apparent. There's a danger of clipping and also accentuating noise. If I look in this bottom corner, well away from the galaxy, you can see that the noise has started to increase. There's another little tool in here called, not the noise reduction tool, but the linear mask. And what this can do is it can protective mask over areas which are dark to stop them being accentuated. So if I click on the linear mask, uninvert it, and let's preview the mask and take a look, and scroll this down until we start to get a little bit of an image. You can see it's starting to pick up the background. I probably need to be somewhere around there. I need to smooth it a little bit, possibly down a bit more. So the black area is the bit that's going to be protected. If I invert it, it goes the other way. In fact, I probably could do with 1. I'll try 1 because that's the most conservative setting. I can undo the preview, and now that you can see, if I just do this, you can see the detail in the dust is happening, but you can't really see the noise because the scale's too small. So let me get rid of that, reset the preview, apply it. So whilst the brighter stars have improved, the background noise is, yeah, it's okay, it's not brilliant, and it probably needs a stronger mask. So I'll have to use a different type of mask, but it just goes to show fixes one thing but creates problems elsewhere. To do my stronger mask, I am going to create one right now and do it. But at the same time, because I notice my stars are getting a little bit on the bright side, I'm going to apply my little histogram transformation to give a little bit of headroom to both ends. On the main image, I'm going to bring up histogram transformation. Whoops. Reset it, put 10% on the highlight and 5% on the shadow so I don't clip, put a negative sign in front, drag it to there. It'll just soften the image, but it means that all the sharpening processes that follow don't create black or white pixels. And now what I want to do is take a clone of that, and I'm going to stretch it so that I get a better mask to put on here. So I'm going to hit preview, and I'm going to pull up my shadow area. I'm going to boost my highlights quite dramatically like that. So that's quite an effective mask. I'm going to hit apply. Now it's still quite granular around there, so I'm going to blur it slightly with convolution. And I'm going to convolve it with 25 pixels, which should be good enough. So that will soften it down, and that will become my mask. Give it a name, which is Loom Mask, and then drag it onto here to mask my image. Move that out of the way. And then that mask, if you just look at the mask, it's white in the middle and black on the outside. So in other words, the sharpening action will occur on the highlights. So now what I can do is take my multi-scale tool. I don't need the linear mask anymore, and I can drag it onto there. And that sharpened it slightly. So if I undo and redo and zoom in closer, you can see that it's now sharpened the details slightly. The stars have peaked up, but they're still not peaking. And the good news is, when I look at the shadow detail and the shadow noise, it hasn't got any worse, which is good. I think that's probably it for the luminance, as far as I want to go in this tutorial anyway. And I'm going to briefly process the colour image and then combine them. Okay, I've rearranged my desktop and tidied a few things up and brought up my red, green and blue stacks. Now, obviously this has come off a monochrome camera and I need to create a colour image. And you do that using the combine process. So I always get this wrong. Oh, I got it right first time. Colour spaces, channel combination. What I now do is I select my red, green and blue in these, and hit apply. Except I have to hit this circle one, which I always get confused about, and it produces a colour image, and if I stretch that image you get that, which is not great. So it is fairly neutral, but it obviously has some issues. So one of the quickest ways of making your images look fairly neutral right from the get-go is to use a tool before you do the channel combination, and that's something called linear fit. And what it does is, without stretching the image, it alters the endpoint of each of your images so that they broadly match, and the general histogram hump, as it were, generally matches, and it gives you a good starting point for finer tuning of the colour. So I'm going to close that for a second and use the linear fit. And I always forget which one that one's in. There it is, linear fit. So linear fit takes a reference image, and I normally choose the red as my standard, and it uses a certain range of the image. It rejects the very, very high value pixels, and all I'm going to do is drag it onto the blue, and then I'm going to drag it onto the green. And the reason it's changed is because in each case there's a screen stretch on the image, and the screen stretch was different each time. If I was to do screen stretch again on these images, they go back to the way they are, but fundamentally they've changed under the surface. If I now apply my channel combination and hit stretch, I get a result that has a more neutral background. Clearly shows that there's some weird gradients going on, but you can now start to work with that and boost the colour and suppress it in the background. And obviously you can see in this bottom corner that I've had some vignetting on one of my filters which hasn't fully corrected out, which is creating its own set of issues. This would be the colour image, and we're going to only be using it for colour information, so I don't need to stretch it to the same extent as I did with the luminance, and I'm not too worried about it being sharp. So what I can do is remove colour noise at the expense of resolution without worrying. So to do that, there are a number of different ways of doing it. But one thing I can do, since I already got it, I've got my loom mask, which is quite useful. I can certainly apply my loom mask to this image, and it's masked off all the background and left the galaxy, but I actually want it the other way around. So if I invert the mask here, what I now can do is neutralize that background to some extent. And one way of doing that is to use the Curves tool. It's under Intensity Transformation, and a very quick and dirty way of making your backgrounds more neutral without necessarily dead neutral, but just reducing the colour saturation, is to pick up the saturation tool and drag it down and hit apply. And then if I now remove the mask, you'll see that the background has certainly become more neutral and the central core still has some colour. So if I step back, take the mask off, it hasn't changed much in the middle, but these colour bands here have been reduced. That's one little trick for a quick reduction of a colour problem on the background without taking out in its entirety. There's one other way of doing it, which sometimes is useful, which is, you can see there's certainly green pixels around here, and there is a noise reduction tool that specifically goes after green pixels because they are so sensitive to our own perception. And it's under noise reduction, and it's called SCNR, which is Selective Colour Noise Reduction. And it defaults to green because it knows what the problem is, and you can apply it and it will take the green and convert it to something else, which is normally the neutral background level. And then what you can do is you can neutralise the background. So another way of neutralising the background is to look at dynamic background extraction. So although these separate images have had it already, we could do it another time round. It doesn't always just take out luminosity gradients, it also takes out colour problems. So again, if I click on a few samples where there's no stars, but avoiding these corners because the corners are where that very faint extent of the galaxy is, which are actually quite difficult to capture. I probably are taking out some Hadron Alpha nebulosity that's around this galaxy by accident, but you can't have everything in this world. And then quickly just hit run. Let's see what the image looks like. Expand the image and you can see what it's tried to take out of the background, and then do subtraction, replace the image, discard the background model. So hopefully that's just a little bit better than it was before, although not brilliant. But there again, this image is quite severely stretched, and it won't necessarily be as stretched in the real image, and also these background values will be much darker, so our perception of colour reduces with luminosity. What I'm now going to do is back off the stretch, which is the screen stretch, and just do a normal stretch with a histogram transformation, reset the tool, and just do a basic gentle stretch, and then another one. But this time I'm going to use the preview because it'll go too far. Something like that will be good. So you're looking for a dim version of what you're trying to achieve. And that image there, I can now do some clever things with, like boost its colour saturation, because after all, this is the colour image. So going back to my Curves tool, so what you might want to consider is if I just simply hit the preview and boost the colour saturation. Yes, the central bit goes, but so do all these bits around the side here. So I don't want to put in the colour that I've just taken out. So what you might want to do is put a mask on this first. So take my loom mask, apply the loom mask to here, or you could use the range mask tool. Now at the moment it's picking out the galaxy and it's blocking off the background, which is exactly what I need. So let's just make that invisible for a second, bring up the preview and increase the colour saturation. So if you notice that if I make it extreme, the middle's changing but the background is not. I want to get some decent colour in, but I wouldn't do that because it will clip, so the better choice is to do this once and then twice. So now we have a colourful version of the galaxy, and you can see that it's got an extended bluer peripheral and these two other galaxies which have now got a little bit of colour in them. I can remove the mask and we can start to actually use this to combine it with the luminance, or I could process this further by boosting certain colours. But I think we probably have been going for some time now, so let's combine this with the luminance and see what result we get. I haven't at this stage combined my hydrogen alpha, which would give a little sparkle to some of the red nebulosity, but that's something that I'm going to reserve for a narrowband special. Under process and colour spaces, there's something called LRGB combination. We've seen this tool before, so disable red, green and blue, identify my luminance channel, which is this one here, leave these two at default. I'm going to reduce the chrominance noise because I'm not overdoing it on the processing at the moment, and it will combine the two together. So there's the galaxy, and you can see that the extent of the galaxy has now grown and you've now got lots of colour. Now this result is quite dim. You can alter the lightness and saturation here. So for instance, if I bring it down, if I remember rightly, I always get these tools around the wrong way, and bring it up, it should make a lighter result. And you can now fiddle with it to improve the dynamic nature of the galaxy. So for instance, the contrast between this middle part and this bit's a little bit low, which probably means you want a classic stretch. So you bring up your intensity transformations and you either use histogram transformation or curves. It all depends on what your taste is. So you can, if I just click on that, pull in the shadows a little bit. So there's lots of different permutations of this. So you could do that, which is interesting. I haven't blown the cores out. I've got good star colour all around the peripheral, including those bright ones. All that effort to keep the stars low in intensity means that they pick up colour. If they get to white, they can't pick up colour. The other alternative, if I just drag that off as an example and roll back this one, I could use curves. Reset the tool, go onto this tool here and put an S-curve in. So rather than clipping the black point, put on the preview, what you can do is you can just suppress it. So what you're doing, you're not actually clipping the blacks, you're just reducing their contrast. So very sensitive, so just bring it down a little bit, bring that up a little bit, and hit apply, get rid of the preview, just move those out of the way. So variations on a theme, you can play to your heart's content to get different feelings or results, and you can also combine two together. If you like a bit of that and a bit of the other, you can take these two and add them with pixel math. Hopefully that's been quite useful. I haven't touched on everything I did to the original image because that also involved narrowband and some quite complicated sharpening techniques which I haven't used here because I needed to keep this within a sensible time frame. But anyway, thanks for watching, and the next one's going to look at narrowband nebulosity and see where we can go with that.